In this presentation, we'll talk about the standard terminologies used in process control. Now, to discuss the concept, I'll take the example we discussed earlier, the Will Sam drown problem. Now, for that particular problem, we asked two questions. One, will Sam drown? The second one, if yes, how much time is available to save Sam? Now, if you look at the second question, it talks about the time, which is a measurable parameter. But about the first problem, will Sam drown? Really, that doesn't tell anything in terms of a specific parameter that's measurable. Now, to get the answers to the questions, let us first formulate the problem from an engineering perspective. What it means that we need to formulate the problem in terms of some variable which are measurable. Now, this will involve asking a set of questions and figure out what additional data and information are required to get the answers. Now, what does it mean by whether Sam will drown or not? Well, now, drowning can be referred here as to the condition when the level of water in pool 2 exceeds some limit. Now, the description of the problem tells you that Sam is a 2-year-old boy. Does it give any particular information to answer the question? So here I need to look at what information are provided and what information are required, what information are relevant to collect. So for this particular problem, you can think about, we may not need to know the age of the boy, rather we may need to know the height of the boy. So in terms of process control, really, we need to get information which are relevant and which are also measurable. Now, next we want to think about the relation between the variable. Now, how the level of water in pool 2 is affected by the flow in pipe 1. Now, if we go back to the problem, a specific diagram we have that we discussed it earlier, that there is a pool here, this is pool 1, and there is a pool 2 there, this is pool 2. So we talked about that. The flow rate coming into pool 1 is going to flow rate coming into pool 1 is going to affect the level in pool 2 because the overflow from pool 1 goes to pool 2. Now, going back to what you're talking about in terms of the relations between the variables, like is the level of water in pool 2 is affected by the valve opening in line 1? Yes, we see that there is a relation. Now, exactly how this line 1 flow rate affect pool 2, from the principles of science, we understand that if an increase in flow 1, that will make the overflow from pool 1 to increase, and that's how it will affect the level in pool 2. However, to exactly know how much level increase will take place, we need to have some additional information about the size of the pool, initial level of water in the pools, and so on. So in this part, we are not going to discuss those things in details. So for that, we will require to find out a mathematical model, and we will see that problem details in the coming lectures. Now, for the time being, what you can think about, if you really want to keep the level of water in pool 2 under control, what can be done? Now we can ask someone to observe whether anyone is drowning or not and do something. Now, to ask someone to see whether someone is drowning or not, that becomes a qualitative problem. So if you look more from a quantitative perspective, that you need to ask someone to measure the level of water in pool 2 and manipulate the flow in pool 2 in a way that can really control the level of liquid in pool 2. You can think of any other idea that comes to your mind. You can think about those as well. Now, it appears that, from our basic understanding, what we know from the basic knowledge about control, you can formulate a problem, formulate a control problem and find some solution here. So for this particular case, what you really need to do, you may have to measure the level of liquid here. What is the level of liquid going on in pool 2? And then do something, compare it with some value that you want, and then use a controller to manipulate here the level flow rate. So that can be done if you have a valve there. Now, just to think about that, you need to measure something, you have to have something to do the calculations, and then you will have to have an action to be executable. So this is from all of your basic understanding about process control that we really use in our daily to daily life. Now here comes the question that, okay, what you need to measure and how you need to measure, and then do you plan to manipulate something, what you manipulate and how. Now all these are leading to the fact that really we are entering into some technical domain and trying to now use some sort of jargons, which are, I would call the terminologies used in process control. These are standard terminologies and you'll have to use it when you are communicating with control engineers in the plant. Now let's look at the terminologies one by one. Now when you're trying to keep the water level at a certain value, this is what is called our control objective. So every control problem starts with an objective. So for this case, an objective should be something which is expressible in a measurable form. So for this particular case, the control objective is to maintain the level of water in pool 2 at a certain value. So this is the maintain the level of water. So that's the key term here. Now every control objective focuses on maintaining a particular variable. For the drowning problem, the variable that you want to maintain is the level of water in pool 2. Now this variable is called the output. So you need to really change your perception from a process perspective. When you use the term input and output in a process perspective, is different from the term input and output when you consider the control perspective. So in control, the output is defined as the variable that is controlled or maintained at a desired value. So we now see that there is a desired value associated with the output. So for the drowning problem, if Sam is say 2 feet tall, we want to maintain the level of water below 2 feet, say 1.5 feet. This is what is called this set point. So we have learned two things. What is the control objective? And the second terminology was what is an output. The third terminology now we get what is the set point. So set point is nothing but the desired value of the output. Now for this particular case, the set point may be some 1.5 feet or something like that. So that's what you understand about the set point. Now to maintain the level of liquid in pool 2, you need to manipulate some valve, meaning that you need to manipulate some flow into the water. In that case, we see that the flow coming in through pool 1 is really causing the overflow to increase, but we have a second input to the to pool 2. So what we can do, we can manipulate that valve. So we can manipulate the flow through inlet 2. So for this problem, this flow rate of inlet 2 is called the input. So the definition of input is the variable that is manipulated to maintain the output at its set point. Again, the variable that is manipulated is called the input. The level of water in pool 2 is affected by the inlet flow rate 2. So also it's affected by inlet flow through the inlet line 1. Now if we choose to manipulate the flow through inlet 2, then that's the input, but the flow through inlet 1 is called the disturbance. So now come to the fourth term. What is a disturbance? A disturbance is variable that affects the output, however is not manipulated or cannot be manipulated. Something like that, we can have the outside temperature may affect the room temperature, but we cannot really do anything regarding the outside temperature. But there are other variables we can, but we may not choose to manipulate those. All these variables will be disturbances. So again, the terminologies we have: control objective. Every control problem starts with an objective. Objective is to maintain a variable at a certain point. That variable that is maintained is called the output. So that's the second terminology, output. And to maintain the output, we need to manipulate another variable, and that variable is called the input. So control objective, output, input, and then in between we learn that, okay, there is another term called the set point. So set point is nothing but the desired value of the output. Now this another term we learned is the disturbance, meaning the variables that affect the output but we cannot manipulate or we chose not to manipulate. Those are called the disturbance variable. Now these terminologies are standard and understood by control professionals. However, there are other names of these terms. So input and outputs are named different ways as well. So we'll learn those later. But next, let's look at some other examples where you can really go through to understand the concept in a better way. So this is a workout problem. So what you have to do, think about the heating system in the lecture room. The first example about the heating system. So if we're talking about a room, so suppose the room temperature is maintained by hot air, and then there is a controller to do that. And the objective, what really the objective for a room heating system? What you can think of? So think about this, go back to the workout problem and pause for a few minutes and come back with the answers. Okay, let's come back. Now for this case, suppose this room heating system, the objective may be to maintain a certain temperature in the room. Now if that's the objective, now think about what is the output then. So going back to the definition of the output is the variable that you want to maintain. So for our case, as simple as that, the room temperature is the output. So now, how can we maintain the room temperature? Now the room temperature can be maintained by manipulating the airflow, hot airflow in the room. So the variable that is manipulated is called the input. So our case, the input will be the airflow or the hot airflow. Now, what are the other variables that can affect the room temperature, but you cannot maintain or you chose not to maintain? The first thing that comes to mind is okay, like it can be the outside temperature. So outside temperature is one disturbance. But for a particular system, there can be many disturbances. Suppose that there is now at certain point there were 10 people in the room and then 10 more joined. So that will definitely cause an increase in the room temperature. So that can be one variable. And if there is lots of activity that generate heat in the room, that can be another variable that's affecting the room temperature. So there may be many disturbance variable. Okay. So the second example we want to look at is the driving problem. So you are driving through mountain roads having uphill and downhills. So you want to maintain a certain speed. So for this case, what is the control objective? So think about it. So control objective for this case may be to maintain. So for this case, it can be to maintain the speed of the car. Now, for our case, that will be the, if that's the objective. Now, what is the output then? So output for this case, nothing but the speed. So that's our output. Now, if that's the output, how can we really maintain speed? So to maintain the speed, you need to make some change in the gas flow. So input can be the gas flow rate. Now, we have identified the control objective, we have identified the output, we have identified the input. What can be disturbance for this case? So the disturbance can be, you can think about one straightforward one is the road elevation. Which often affects the speed of a car. So now in this two example, you can think about the output and input. Those are always some variables, and so is the disturbance variable. So those are output, input are always measured variable. The disturbance, some of those can be measured, some of those cannot be measured. But output and input always will be some measurable and measured variable. So keep that in mind, that output and input are always measurable variables. Now there are two other problems here about the shower problem. So consider the shower problem based on the what you need for a comfortable shower. So if there are more than one objective, you can identify and you can do that problem. So please do this at your own time, and then we'll discuss it in our next class. So finally, to wrap up, we have few things here. This talk we learned about the control terminologies, especially the variables that we identified. What is an output? What is an input? What is a disturbance? And then every control problem starts with a control objective. So first you need to define the objective, what you want to maintain, and that really defines the output variable, and then depending on which variable you want to manipulate, that defines the input variable. Now this choice of input and output, that's also called selecting the control configuration. So whenever you are trying to communicate with control engineers, you need to use these standard terminologies, and again you need to think of this from a control perspective, not from a process perspective. From process perspective, output and input for a process may be totally different. Output and input for control are measured variable, and you need to think about from the control configuration, what are the input, what are the output. Thank you.